Thanks very much. So, good afternoon, everyone. My name is Jibril Frej. I am a postdoc at the Machine Learning for Education lab at EPFL, and I'm going to present our perspective paper, Course Recommender Systems Needs to Consider the Job Market. So first, about the perspective, who are we? We are academic researchers that are working with industry practitioners to develop and deploy a course recommender system that are aligned with the job market. So in case you don't know how course recommender system works, it's the same as any other recommender system. You can use user item interaction matrix to train your neural network. You can also use knowledge graph to inject some knowledge within your neural network. You can use text description or features of the items. Same for the users. In that case, you can analyze their resume and so on. But something that is almost never done is to consider the job market when developing a course recommender system. So what are our contributions in this perspective paper? First, we identify some desirable property that such course recommendation system should satisfy. Then we develop and deploy a prototype that satisfies these property. And finally, based on our experience, we propose several research directions that could help with this domain. So first, properties. Obviously, the first one is course recommendation system should be aligned with the job market. That is, they should consider the skill demand and the skill supply, and when possible, recommend a course that teaches a skill that is in high demand and low supply. Second is this system should have as minimal supervision as possible. As you probably know, manual labeling is very expensive and the job market is dynamic. So here, for example, it's a logarithmic scale, so it goes up very fast. So Python is very trending, Rust is exploding, but Perl is dying. And if we had to label the job market every month of every year, this would be very, very expensive. So that's why we should have systems that are as unsupervised as possible. Next, this system should be sequential, that is recommending a coherent sequence of courses. For example, if you have a front-end developer that would like to now become a retrieval augmented generation developer, one course will probably not be enough for them. Probably first we would need to recommend a course where they will learn Python, then based on what they learn about Python, they will be able to take a course that does NLP, and then maybe they can get a course about RAG. The fourth property is that the recommendation should be aligned with the user goal. So even if we consider the same profile, but a user with different objectives, the recommendation should be different. Like if we have a user that has a very specific goal in mind, he wants to land a front-end developer job, maybe a course about HTML will be relevant for them. Or if they have something a little bit more vague, they would like to specialize in Python, then we should recommend a course Python for Expert. Or if they have something even vaguer, they just want to increase their marketability, then maybe they should learn Rust because it's becoming very trending. And the last one is explainability. Taking a course is very expensive, both in terms of time and money. And providing an explanation as to why this course is being recommended would increase the trust and therefore the engagement of users. So now about the prototype that we developed. During the offline phase, it's basically pre-processing. So we scrap job posting from the web, and we pre-process them to extract the skills that are required for each job posting. And for courses, we also pre-process them, but in that case, we have two sets. The sets of required skills, what do you need to be able to take the course, and what is being provided by the course. I don't have time to provide the details of how we did this, but basically it was a few-shot learning with large language model and a few rule-based function over strings. So during the online phase, we have a user that uploads their resume. So we use the same as before. We extract the skill that they possess. And we filter the courses that are not relevant to them. So how do we do that? Actually, we defined a function, a user course relevant function, and the way that we define it, we got inspiration from axiomatic information retrieval. So for those of you who don't know it, the idea of axiomatic information retrieval is to list a set of constraints or property that a relevance function should satisfy, and then we define the function to satisfy such properties. So the first constraint that we define is if we have two users and one has more of the required skills, then that user should have a higher relevance with the course. Same with the mastery level. If we have 2 users, but one is an expert in a skill and the other is a beginner in the required skill for the course, they should have a higher relevance. And the last property is, if someone has all of the provided skills, so if they already know everything, then this course is not relevant to them. It should not be recommended. If you want to have the detail of the equations, please have a look at the paper. So using this function and a threshold, we're able to remove all of the courses that are not relevant to that user. And then we are making the actual recommendation by considering the skills required on the job market. So how do we do that? Our recommendation criteria is to maximize the number of applicable jobs that this person will be able to take after learning the skills taught by this course. So how do we compute the number of applicable jobs? Just like before, we got inspiration from axiomatic IR. So we defined a user-job similarity function that follows a similar constraint as before. So the first one is the same as before. If you have 2 users and one have more of the required skill for the job, they should get a higher similarity. Same for the mastery level. If one is an expert in a skill that is required and one a beginner, the expert should have higher similarity. But the last one is different. If a user has all of the required skills and mastery level for the job, they will get maximal similarity. So the idea is, if you know more than it's required, you will not be more attractive as someone who knows only everything that is required. So once again, we use this function and a threshold to compute the number of applicable jobs that this person will have after taking the course. And then we update the profile of the person with the new skills they have learned, and we repeat the process. So with the new skills, we find maybe a new course that they can take, and we repeat this process. So very quickly, our prototype does satisfy the different properties that we listed before. It is aligned with the job market because it does consider the skill demand. It is minimally supervised. We only use few-shot learning for the skill extraction, but everything else is rule-based, and for the few-shot learning, we only had to manually annotate a couple of examples, less than 10. It is sequential. As I just said, we can update the profile and repeat the process. It is aligned with the user's goal. So in that case, we assumed an unrealistic goal. That is, I just want to maximize my marketability. But after that, we updated with the company, we updated the user goal, and it's quite easy to change it to have more realistic goals. And finally, it is explainable using the skills that are provided by the course and that are required by the job. So for example, we could say, you should take this course about Rust because you will learn the skill Rust, and then look at these 10 new jobs that you will be able to apply to thanks to this course. About the evaluation, sorry. So we have a sequential decision-making process where at each step we can choose a course to recommend, and we have explicit criteria to maximize. And the question we ask ourselves is it worth it for the company to try to implement reinforcement learning? I don't know if some of you have ever done reinforcement learning, but in practice it's quite tedious. So what we did is basically we compared a greedy heuristic with 2 reinforcement learning algorithms. So here it's the number of courses that we are recommending in the sequence. And what we found was when it comes to the number of new applicable jobs that you can take for shorter sequences, greedy seems to be better than reinforcement learning. And for efficiency, actually the RL approach are a little bit better than the greedy approach, because for the greedy approach, we need to consider all of the possible courses, update the profile every time, see how many new jobs they can apply to. So it's quite tedious and it doesn't scale very well. Right now, the data set is relatively small, so for now, greedy is enough, but as it scales in the future, maybe we will have to come up with another solution. So all of this leads us to 6 different research directions to try to pursue this domain. The first one is about course recommendation datasets. There are very, very, very few publicly available large-scale datasets for course recommendation. To my knowledge, we could only find 2. One that is very noisy. The problem is simply universities, they don't want to share this because of ethical concerns or legal concerns or privacy concerns. And companies like MOOC platforms, they would like to keep their competitive advantages, so they don't share that either. One possible research direction that could help the university share their data is privacy-preserving synthetic data generation. So the idea would be you have a university with a private data set, and if they use such type of method on their data set, they will be able to generate a synthetic data set that has the same distribution and property as the private one, but that does not break the privacy of its students. The second is evaluation of the alignment of the recommendation. Because in this case, ranking metrics like NDCG, MRR, and so on, they're not enough. With a ranking metrics, you cannot evaluate the impact of the recommendation on the user's goal, and you cannot evaluate also the alignment with the job market. And also, even if you have a data set that you use to evaluate your system, how could you try to mitigate the biases in the historical data? So if I take the same example as before, imagine you have a data set that stops here at 2012. So recommending Rust in 2012 is a terrible idea, but now it's extremely important. So what we would like to be able to do is to still use this data to evaluate our system, but without biasing it too much towards the old trends. Another research direction that we identify is how can we estimate the progress of the user's goal? So given a goal and a user's profile, how can we know how much they have progressed towards their goal? So the way that we did it was with handcrafted functions, rule-based. But something that could be interesting is using large language models or other NLP approach and a natural language description of the goal. If we're able to do this, then we will be able to take into account any goal that is formulated in natural language, whereas in our approach, we have a very restricted set of goals. Next, explainability. If you have a very large sequence of courses, like 4, 5, or 6, explaining this can be quite overwhelming. So one way, of course, to try to address this issue, again, is to use a large language model to try to summarize all of this and generate good explanation. But there is also work to be done in HCI, human-computer interaction, by exploring different visualization technique, which one is the most effective to convey the explanation. Then we have unsupervised skill matching. So what we did before was for course catalog, job posting, and resumes, we were able to extract the skills that they possess. But actually, the same as for course recommendation datasets, there are very few publicly available datasets that can do that, and most of them are specific to a single taxonomy. So one thing that has been done already for job posting is to try to use LLM and a taxonomy to generate synthetic datasets, and then train another model on it that is, for example, not an LLM that you can use efficiently. And also something that is largely unexplored is the unsupervised master level assessment. So you have a resume. I know that you know Python, but are you a beginner, an expert, intermediate level? This has been largely understudied. And last research direction is unsupervised taxonomy construction. So as I said before, the job market is dynamic. Some new skills are emerging. Some of them are becoming less relevant. So if you have a taxonomy in the form of a knowledge graph, you can just simply use knowledge graph completion, but that would only add new links to existing nodes. But what if you want to add new nodes, a new skill? For example, a few years ago, prompt engineering was non-existent. So something that could help in this domain is emerging skill forecasting by trying to analyze the different job posting and try to predict which skills are going to be in high demand in the future. To conclude, we have identified several properties that course recommendation system should satisfy. We proposed a prototype that satisfied such properties, and we have identified several research directions that will help pursue research in that domain. The code and the process data, so not the raw text, is available on GitHub and also on this QR code, and the QR code is also on this slide. Thank you very much for your attention.